The era of the lone fighter is ending. Future air combat is not about heroic pilots fighting one-on-one. It is about teams operating as a single, cohesive system. Modern air warfare has become too complex for individual platforms to dominate alone. The sheer volume of censored data, electronic threats, and networked assets demands a new approach. Sensors, data, weapons, and decisions must all work together seamlessly. This video explains why future fighters are designed to fight as teams, not as independent hunters, and how this doctrinal shift is reshaping the very concept of air superiority. The modern battle space is an overwhelming torrent of information. A single pilot is simultaneously tracking multiple sensor feeds from radar, infrared systems, and offboard assets, while also managing electronic threats and coordinating with friendly forces. No single human can process this deluge of data in real time without becoming saturated. This cognitive overload is a critical vulnerability. Team-based operations are the solution, designed to distribute this immense cognitive load across multiple operators and platforms. By dividing the tasks of sensing, processing, and engaging, the team can handle far more complexity than any individual member. The operational takeaway is clear. Teams are designed to prevent human saturation, ensuring that decision-making remains effective under extreme pressure. Future fighter teams will achieve this efficiency through role specialization within the formation. Instead of every aircraft being a jack-of-all-trades, formations will consist of specialized nodes. Some platforms will be sensor-focused, using advanced systems to build a detailed picture of the battle space from a standoff distance. Others will serve as dedicated weapon carriers, or arsenal ships, loaded with a variety of munitions to be launched on command from other assets. Still others will act as electronic warfare nodes, disrupting enemy sensors and communications to protect the entire team. Effectiveness comes from this intricate coordination, not from simple duplication of capabilities across every airframe. The core insight is that specialization increases the overall efficiency and lethality of the formation, allowing it to achieve effects that are greater than the sum of its parts. This specialization is only possible through a shared situational awareness. Networked teams operate with a common fused battlespace picture, where data from every sensor is shared and integrated in real time. This unified understanding allows for superior threat detection, as a target seen by one platform is instantly visible to all. It enables perfectly coordinated engagement timing, where multiple weapons from different aircraft can strike a target simultaneously from different directions. Crucially, it also reduces the risk of fratricide, as the position and status of every friendly asset are continuously updated and displayed. The team fights with a single collective mind. This shared awareness creates a decisive collective advantage, turning a group of aircraft into a unified combat system. This team structure also creates a profound level of resilience. A single, high-value aircraft operating alone is a fragile asset. If it is detected and engaged, the mission may fail. Teams, however, are far harder to defeat. The distributed and redundant nature of the formation means that if one asset is lost or its systems are degraded, others can dynamically retask and adapt to continue the mission. A sensor platform that is forced to withdraw can have its role filled by another member of the team. A weapons carrier that expends its munitions can be replaced in the engagement sequence by another. This inherent redundancy dramatically increases the survivability and persistence of the force. The fundamental principle is that teams can absorb losses and equipment failures far better than individual platforms, ensuring mission continuity in a contested environment. Finally, the concept of the team is expanding to include non-human members. Human-machine teaming is a cornerstone of future air combat doctrine. Manned fighters will no longer fight alone, but will act as command and control hubs for a suite of unmanned systems. Pilots will orchestrate the actions of autonomous drones, loyal wingmen, distributed sensor platforms, and disposable electronic warfare assets. In this model, humans provide the critical elements of ethical oversight, complex judgment, and strategic intent. The machines, in turn, provide scale, endurance, and the ability to take risks that would be unacceptable for a manned platform. This fusion of human judgment and machine capability is the next evolution of air power. Teamwork now includes machines, fundamentally changing the calculus of air combat. In summary, future fighters are not designed to dominate alone. They are architected from the ground up to connect, coordinate, and adapt, as part of a larger system. The pursuit of air superiority is no longer about which single aircraft has the best performance specifications. It is about which force can build the most effective team. Doctrine is triumphing over raw performance, and integrated systems are proving more decisive than individual platforms. If this episode reshaped how you view air combat, like the video and subscribe to Cut Everything. In our next episode, we will examine the cornerstone of this new doctrine: loyal wingmen, the rise of combat drones. Comment below with your analysis. Do unmanned teammates make pilots more effective or more vulnerable?